Inverse functions. The inverse of a function undoes the original function. What does that mean? Formally, f and g, and we're going to assume that they're both functions, are inverses of each other if the following is true. If f of g of x equals x and g of f of x also equals x. Generally, for the problems we do at this level, if one of these is true, the other is true as well. But this is the formal definition of an inverse, in case you see that. A little bit more informally, or intuitively, suppose that f and g are inverses of each other. And let's say f of a equals b. Then g of b equals a. That is, we could say f takes a to b, like that, and the g takes b back where we started, to a. That's what I mean by an inverse undoing what the original function does. The notation for the inverse of f is that. It's f to the negative 1 power of x. We have to be careful in mathematics because this notation could mean actually f to the negative 1, which is 1 over f, which is not the inverse of f. So when we're dealing with this notation, we need to be clear which one we mean. Do we mean the inverse or do we mean 1 over? So when we use it in this video, f to the negative 1, if you would, is going to represent the inverse of f. Let's do an example. Suppose that f of x equals 3x plus 2, and let g of x be the inverse of f of x. We want to find the value for g of 5. Well, up above we saw that g of 5 equals some number, I'm going to call it a, means that f of a equals 5. So the x value in the g function becomes the y value in the f function. And the y value in the g function is the x value in the f function. We'll get back to that in just a little bit after we solve this one. But we can say f of a, which is going to be 3a plus 2, equals 5. And then we can solve for the value of a. We see that 3a equals 3, and that a equals 1. So f of 1 equals 5, which means that g of 5 equals 1. And so one really important thing that we see from this is that when we're finding inverses of each other, we can switch the x and the y values. So generally speaking, when you're asked to find the inverse of a function, I recommend starting by switching the x's and the y's. And then we solve for y. That is, then we'll solve for the new y. So let's find inverses of some functions. And let's start with the first one. Let's say f of x equals negative 4x plus 1. What does f inverse of x equal? Recall that f of x we can write as y. So to find the inverse, I'm going to switch the x's and the y's. That is, y becomes x, and then x becomes y. So this y right here is really y inverse or f inverse. But so that our notation doesn't get messy, I will leave it as y and then fix it at the end. So we've switched the x's and the y's, and now we're going to solve for y. So I could subtract the 1 and then divide by negative 4. And that is my new y, or really my new y inverse. Let's try another one. Let's say f of x is a line that goes through some points. How about 8, 3? And let's just give the slope along with this one. And has a slope of 5/4. If you recall from the video when we were doing lines, to write the equation of any line, we really need three things: an x value, a y value, and a slope. And we have those things. And now we can write the equation. We can say y minus the y value equals the slope times x minus the x value. Or y equals 5/4 x minus 5/4 times 8, which is going to be 10. It's 40/4. And then add the 3 from this side, which is going to give us y equals 5/4 x minus 7. So this is our original function. And now we can find the inverse by switching our x's and our y's. X equals 5/4 y minus 7. Really, again, this y is our y inverse, but we'll leave it as y for now. And then we can solve for the y value. We'll add 7 to both sides first, and then we can multiply both sides by the reciprocal of 5/4. That is times 4/5. And that equals y. Really, this is y inverse. So y inverse, or f inverse of x, equals 4/5 x plus 28/5. Let's do a couple more that aren't linear. Again, we're finding the inverses. And suppose that our function is the square root of x minus 4. And we'll put a limiter on our domain for x greater than or equal to 4. That way, we're only taking square roots of non-negative numbers to get real answers. I'm going to draw the picture really quickly. And you're not necessarily required to remember this, but this should ring a bell if you've studied algebra earlier. Here's our graph, f of x, with x greater than or equal to 4. There's x equals 4 right there. And notice I can add a little bit extra down here that y is going to be greater than or equal to 0, or f of x is greater than or equal to 0. Let's find the inverse of this. We're going to start by rewriting, so y equals the square root of x minus 4. And then we will switch our x's and our y's, giving us x equals the square root of y minus 4. We want to solve for y now. We'll do that by squaring both sides, giving us x squared equals y minus 4. And again, this y is really our y inverse at this point. Adding 4 to both sides, we get y equals x squared plus 4. And again, this is really the inverse of our function. And if I were to graph this, and you may recall how to graph parabolas, we'll certainly talk about this formally in a later video. But that would be the graph of x squared plus 4, and notice a couple things. Notice that for the function, x was greater than 4 and y was greater than 0. For the inverse, y is greater than or equal to 4, and x is greater than or equal to 0. So not only did the y's and the x's change, but our domain and range changed as well, which shouldn't be a surprise considering that the domain is the x or inputs and the range is the y or outputs. One more function, and let's make this one a little bit more complicated looking anyways. So what if we had the function f of x equals x over x plus 1, which I'm going to rewrite f of x as y. Should we do this any differently to find the inverse? The answer is, of course not. We will replace all our x's with y's and our only y with an x, just like we start any other inverse problem by doing. And now we need to solve for y. We got to get the y alone. So how can we do this? Well, the algebra on this one is a little bit more complicated, so I want to walk you through one of these. The first step I would do is I would multiply both sides by y plus 1, because I don't really want a denominator in my problem. And then I'm just going to keep going and see how far I can go or what I need to do to get y alone. Now, even if you're not sure what to do or why I'm doing it when I'm doing it, you might think, well, even though I don't know what to do or what I should do, I can distribute. So I'm going to distribute this thing and see what happens. So we end up with y equals xy plus x when we distribute the x. Now, anytime we want to solve for a variable, in this case y, we want to isolate it, meaning we want all y's on one side. So I will subtract xy to get all of my y's on the left side. Can you think of what to do next? Because I'm really 2 steps away from the answer. If you thought on the left side, factor out the y, you're correct. Why would I think to do that? Well, number one, I can. And then when I do that, even if I wasn't sure why I was doing it, I see that in the next step, I can get my y alone, simply by dividing both sides by 1 minus x. And recall, of course, that this y is really my y inverse or my inverse of f.